Now, as you can see, the board is not rubbed yet, as to take you through from the previous discussion, and I will go ahead with the same example. And I want to, as I said earlier, that I want to establish some relation which could be taken as some formula also for probability. So, as you can see, the last example for us, by tossing a dice, what could be the different probability results when our preferable or favorable outcome is changed. So that means what we need as a result out of the total possible results, and what would be the probability accordingly that has been taken care here. So we have taken two such examples where our choice of preferable result, choice of result or preferable result is only a number, any number. It is not distinguished which number we need. Any number comes, as we case of Ludo we have said. And further, for any other circumstances, if the things are needed in an odd number or any even number, then how that being changed. Now, taking this example further, we need to establish some relation where my requirement is such that if any number outside the possible outcome is meant or required, if such case is to be established, and for that what will be the possible probability, then logically we'll approach on that. How? What I said, in any, if any number outside the possible outcome. So what are the possible outcomes? 1, 2, 3, 4, 5, 6. That's all. Now let's say, we need number 7, for instance. Number 7. Whether will you get number 7 if I toss a dice? So people may say you are asking foolish, but that also an event where, because we talk about the uncertainty. So this is one kind of uncertainty where we need some number which is not even exist in the experimental data. So straightway people can say the probability of that event where we need 7 has to be equal to 0. Why this is being discussed? We know that result definitely will come 0, but to establish the limiting condition of probability, that means anything that will stop thinking about probability not below 0, because this is the case we have understood. Any other case that would not give you some result which will be less than 0. I mean to say, you cannot get any experiment result where the result will come negative. Negative means your preferable or favorable outcome is, how will you define that? Below 0, I can ask something which is not possible. That means this is impossible case. So this is called impossible probability. This is impossible case or probability, you can say. So out of except this, all other are possible, because there are two things may happen, possible or impossible. There are two side of coin, head or tail, like that, possible or impossible. So possible is there where your probability will give you some result, probably that will give you the fraction, result in fraction, and this is the limiting condition where impossible things comes, so that gives you 0. Impossible means 7 I will not get. How? The probable result, probable outcome or favorable outcome will be 0, because 7 would never come, and the total possible outcome is 6, so that way it is 0. So this is one of the limiting condition. Fine. I think I have told so many things to make it understand that why that 0 will come. So if this is the one boundary, what would be the next boundary? So boundary is this, and another boundary you need be there. This boundary is 0. In between any result will give you probable result of probability of any event or experiment. What is the next one? So the next one definitely be what? If probability of something, it says m by n, where m is favorable outcome. So what outcome? So what would be the, logically what would be the maximum of such, where m is equal to n? That is possible, because if I want all the results, that is possible results that we can ask. But if we can say that if m is more than n, what is that signifies? I need something which is not existing, which is beyond my possible results. The same thing I have discussed here. If I ask something more than n, that means what? I am asking which is not in range. The same thing I have discussed. So probability of that when I cross m, the probability of getting other things are all 0. So this will match this one. So that I have covered. Getting m less than n possible. Till what? This cannot be negative. So it will be confined to 0, and maximum case where m is equal to n. If m is equal to n, I will get 1. So the other limit will be 1. So the probability of any event must lie between 0 and 1, including those terminal values. 0 also possible, 1 also possible, and in between any value. Understood? So this is the range of probability of any event which is not biased, which will give you a definite results. Understood? Okay. So in this, one more concept will arise, that also to be discussed by taking an example. Now we have thought about tossing a dice where the result may come 1, 2, 3, 4, 5 and 6. Okay. Now for any particular number, if we talk about, we need 1 as answer or outcome, 1 as definite outcome. So that means this is my favorable condition, 1 as definite result I need. Okay, this is one example. So what is the probability for that? The favorable one by the total outcome. This is the formula, m by n. Understood? Now there is a context in this. We need the negative of that. There is always a positive aspect or negative. I need 1. If we need when 1 would not be an outcome. Okay, so I don't need one to come. So that means I need all other to come. When I discard one of the result out of the total probable results, that means I need all other results except that one. So what would be my probability? I mark it by P bar. Somewhere it also can be done with P E dash. This is also a representation for this. Okay. So this is representation, and that would be all other all other favorable outcome. Now this will be my favorable outcome because I don't need one except that I need everything. That is the impression, the negative impression of that. When I don't need one, I need everybody else, isn't it? So my favorable outcome is 5 out of this. Fine. Now if we add these two, what we will get? We will get 1 by 6 plus 5 by 6, that is equal to 1. Okay. So that means we can describe it in words. How is that? The probable outcome and plus not probable outcome together will give you 1. So this is probable outcome of any event, and this is not probable outcome or not happening. This is happening. This you can say also happening or certain result. I will not take it as certain because certain will define something else. Happening plus not happening. This we can say. Happening of any event plus not happening of any event together will give you unity. This is one rule. So that means we can use it as a formula. 1. Okay. You can use it as a formula. So that means you can say in other way that if PE plus PE bar or E dash equal to 1, then to get PE dash bar, I can get it directly by doing 1 minus. This you can use as a formula for any direct evaluation of any problem. Okay. And few more definitions need to be understood. Those are first thing, the sample space. What is sample space? Okay. This can be defined as the number of possible results. That means number of possible results. Okay. Now if I take an example of tossing, the same example I will quote, tossing a coin. So how many number of possible results possible? Either head or tail. So 2 numbers. So my sample space will be head and tail. This is my sample space, and if you count it, it is 2. So any sample space is the number of possible results. Here you can say it head or tail in words, or 2. Total number of sample space is 2. Same, tossing a dice, the sample space is 6. 1, 2, 3, 4, 5 and 6. So total This is my sample space. 1, 2, the result is 1, 2, 3, 4, 5, 6. You name the results. Head or tail, count will be 2. Number of possible results. When we'll calculate the probability, then we'll use the count. Otherwise, the sample space is defined as the number of defined results. Head is defined result, tail is defined as 1, 2, 3, 4, 5, 6. These are the sample space. This is the event A, an experiment. Okay, an experiment. So tossing a coin once, is an event. So doing any experiment once is event. Understood? This is event. Now experiment doing several event. So if I toss a coin several times, so this is called the number of experiment. This is number of experiment. So doing number of events is number of experiments, we can say. And this is okay. Range already I have described. Range of probability is between 0 to 1. This is range. And anything okay. Now the kind of I will give you some you can say the definition or the type of probability, definition of few probability which could be taken as a type of probability. The type of probability, I will come to some more examples later. Before I need to complete this part, where because in example I will describe all those terms which are standard. So before than that, familiarization of those terms is very much essential. So types of probability. The first type is theoretical. Second is experimental. These are being taught in lower study, and where this is only related to the mathematics. The third one is your axioms. Axiometric probability. This basically we don't teach in the lower classes. This basically needed for higher study, and where uncertain means not definite result can be predicted. Just for example, if I say tossing a coin will definitely give you head or tail, not beyond that any result. But if I say how will we predict raining today? So is that so simple, just tossing a coin? Like nothing. Nobody, not only me, nobody can predict. Even he is so keen and knowledgeable about the weather forecasting or climate forecasting of any certain area where he has worked for several years and all that, even though it's not definitely can say that today there will be rain or not. Okay, so this kind of things is predicting of such things are again is having some proximate result, not the definite result. and that is being studied in this chapter of axiometry, because this are depends on so many of rules. Axioms is basically the rules or the formula that is being derived from past result. There may be so many of criteria behind that. Some of these are past experience. If I take the example of raining, so in some areas, year wise, what are the probability on a certain part of the year how the weather behaves. Generally we predict this is our monsoon season, and this time to this time there will be raining season. But even though on certain day on certain time cannot definitely say somebody by seeing even the cloud and all that. So one of such is past experiment, past experience, or any surrounding effect of any nearby area where monsoon is going and the effect would come. Some depression has happened, and so many things being accumulatively that prediction is done as a weather forecast. And even then, if somebody can say definitely that today will be rain, that may go wrong. So I'm not going to details into that, but axiometric study basically in statistics, weather forecasting, such things that that has no definite outcome can be predicted. That is all proximate results make predict, and that depends on so many of things. That is not a straightforward experiment, just like a tossing. So we'll study the things for clearing our basics, and we'll concentrate on these two subjects only as of now. So moving to that, what are these kind that we need to know? Theoretical means that we have described right now. Theoretical means where we can predict definite result. So where we can predict a definite result, just tossing a coin once, tossing a dice once. That means tossing a coin once means where you can predict any of the such result, head or tail. Okay, but that may go wrong if I say tossing a coin, if give us head first time, tossing it for second time definitely will give head is not possible. So when you do the repetitive experiment, then result with the same probability that we have got for the first experiment will definitely cannot say that we will get the same result in second event or experiment. That means if I got head for first time, there will be possibility I may again same will get head or tail, and that is not interlinked. Even if I produce a probability result of half, I cannot predict it. It can be head in the second time. So in two consecutive experiment, my probability will be head or could be head or tail, could be head, could be tail head, or could be tail tail. So my possible results is now become four kind, and my expected result getting head every time. So this is one. So now see, my probability changes when we do the repetitive experiment. So for once it may definitely be half. It cannot change. Either I will get head or not. So that is the probability of half. But when you do the same experiment twice, my probability changes to 1/4. So likewise, the theoretical experiment is when you are doing that experiment once for a time, and that is having an experiment that is having a probability of such. When you do the thing experimentally twice or several times, the result is become different, and that's why the experiment probability results is defined as m by n. That means number of favorable outcome divided by number of possible outcome. Okay, whereas the experimental probability can be defined as number of actual outcome by number of possible outcome. Not actually, this is number of favorable outcome again, number of favorable outcome divided by number of possible outcome. So in this case, how it is different to this? Because here number of possible outcomes will be multiplied by the number of experiment. That means if one possible outcome for one experiment is 2, so if I do the experiment for let's say z number of time, so my possible outcome will be n into z. Okay, and my favorable outcome may be 1. Favorable outcome getting head, that means twice head, and this will be the one option among all 4. But here as number of possible outcomes has increased from 2 to 4. These are the possible outcome, head, tail, but my choice is getting twice head. In this case getting head, and this case also head, but I will represent as getting twice head, then only I can say that I am getting head. So in this case my preferable or favorable outcome is 1, but whereas my possible outcomes has increased by number of experiment multiplied by the possible outcome for one experiment. If it is for dice, I will get possible outcome is 6, but if I do it for 2 times, my possible outcome will be 2, but getting any number, that means if I want to get 1, so both time 1 is my preference, so this is my favorable outcome is 1. So that case my experimental probability will changes. So these are the 2 variety of probability. Understood? I will end up here. In later video I will come with few more terms which is related to probability. Then I will solve few more examples that is given in the NCERT textbooks. Then I will do more exercises. Okay, there is no much theories there, only this part is needed for lower classes. This kind of concept probability may be intellect somewhere in permutation, combination, and your you can say statistics, and so many subjects. It is some or less it is being related. I will not jumble all the subjects together because that will be confusing for me. I will relate these subjects along with its own example. Okay, so I will move like that, and then after I will move to a subject of physics together. Okay, so thank you for now. Good night.